All right, so let's finish up problem 2. Let's just review a smidge with it. It says a fan has 15 angles meeting at the center. So here's 15 angles right here meeting at the center. What are the measures of the base angles of the congruent isosceles trapezoids in the second ring? And so I highlighted that second ring here, and here's that isosceles trapezoid right here. And they've given you this is angle A, this one here is angle B, and that one's angle C. What do you know about angle B and C? They're supplementary because they form a linear pair. Okay? And what do we know about isosceles trapezoids? The fact that they told you it's an isosceles trapezoid, what are the things that we know about the isosceles trapezoid? Legs are congruent. What else? Base angles are congruent. So what that tells me is this angle B is congruent to that angle there, whatever it's called, so it would be called B as well. And then this angle here is congruent to this angle there. And if these are parallel lines, aren't these same side interior angles on parallel lines? So don't we know that those are supplementary as well? So whatever angle C is, isn't that going to be angle C there as well? If these are supplementary and these are supplementary, then C and that angle must be the same. And then the only other thing we know about isosceles triangles is that the diagonals are congruent. And I don't know if that's going to come into play here. And so they want to know what are the measures of those base angles. So they're walking you through this over here. We started with the fact that, okay, we're going to find angle A. To find angle A, which is right here, one of these, all the angles here, because they form a circle, add up to 360 degrees. So that's why they're taking 360 degrees and dividing it by 15. And so we got 24 degrees. So I know that angle A is 24 degrees. Isn't this whole outside here, right here, a triangle? Isn't this an isosceles triangle? Wouldn't this be the vertex angle? So if this angle here is 24 degrees, then this angle here and this angle here are the same. So they're going to walk you through that. I'm going to subtract that from 180 and then divide it by 2 to get each of those angles. So here we go. Here's how we find B. We're going to take 180 and subtract that 24 degrees. So what's 180 divided, what's 180 minus 24? 156 by my opinion. We have 156 divided by 2, which is what? 78. And so that means that this angle all the way over here is 78 degrees. And that means that this angle is 78 degrees. Isn't this going to be an isosceles trapezoid as well? Right? And so aren't those going to be supplementary? So they're going to walk you through taking 180 minus that 78 degrees to find angle C, and we got the 78 degrees from here. What does that give us? What does it give us? We're slow this morning, 102 degrees. And so angle C, squeeze that in here, is 102. Now we can also conclude that if these lines are parallel, aren't B and D corresponding angles on parallel lines? So isn't B also 78 degrees? So we don't even have to go through. Oh, did I put the wrong one for C? Oh, I did one or two. D, we already found D. We already found D before, which is 78. Since I wrote all over mine, I can't see it. Hold that down. Oh, well, B and D are the same, right? So the measures of the base angles of the isosceles trapezoid are, so here's your base angles. This is 78 and that's 78. What's this one going to be? If that's 78, what's this one? They're supplementary. So isn't it 102? So we've got 78 degrees and 102 degrees. So as that fan gets bigger and bigger and bigger, those angles are going to remain the same. All right. So next page. Example 3. So second MN is the mid-segment of the trapezoid PQRS. So remember, we come up with two formulas for the mid-segment. By definition, the mid-segment is equal to half of the sum of the bases. So B sub 1 and B sub 2 are going to be the bases. Or, as I said, I like the following formula better. If I multiply both sides by 2, get rid of that 1/2, I would have 2 times the mid-segment is equal to the sum of the bases. I like the second formula better, personally. And so instead of, we're just running you through all of these, we're not going to go through the reasons for all the steps. So let's run through it using our formula over here. So I want you to take 2 times the mid-segment equals the sum of the bases. So we just did this in a homework problem, so I want you to do that on your own following the second formula. And then you tell me, looking at the work, which formula seems easier. And if you don't get the same answer as they did, something's wrong. What they did not find for you was MN. So I want you to find MN as well. And then share that with those around you. Did we all get the same answer of 6 for x doing it the other way? Yes or no? Pardon? So let's look at that. So if I replace the mid-segment 2x plus 11 in the formula here, and then these are the two bases, the 10 and the 8x minus 12. So they're always the parallel sides. And so all I did was distribute the 2. I got 4x plus 22. And then I collected the 10 and the negative 12, which gave me that negative 2. And so then I subtracted the 4x from both sides, and then added 2, giving me 24 equals 4x, and then divide by 4. Finally, because they want MN, and remember, if you have a multiple choice question, 100% of the time they're going to have 6 as an answer choice, and it's going to be completely wrong, marked completely wrong, because you didn't read the directions, but you understood the problem, which is a shame. So always make sure you're aware of what is the question asking for. Well, they also want what is mn, which implies the distance from m to n, which is 23. 2 times 6 is 12 plus 11. Are we good with that? Pardon me for yawning. Okay, so then we'll move on to kites. Some of you questions, a kite, really? A shape? Absolutely. So a kite is a quadrilateral with two pairs of consecutive sides congruent and no opposite sides congruent. Because if you have two consecutive sides that are congruent and opposite sides congruent, wouldn't you have a square or rhombus? And it is neither a square nor a rhombus. So on our visual display over here, we're going to add one more. And it is not part of the trapezoid family. It is, grab a blue pen. It is just a quadrilateral. So you've got your kite as part of the parallelogram family. And then its definition. Well, let's use our definition. It has two pairs of consecutive sides congruent and no opposite sides congruent. So that's your last quadrilateral that we're learning. And we have a theorem. And the theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. What is that similar to? What other figure, what other quadrilateral has perpendicular diagonals? The rhombus. So the trapezoid, the isosceles trapezoid had congruent diagonals, which was like the rectangle. The kite, and any kite, has perpendicular diagonals, just like the rhombus. And if you think about it, if you were to make a kite, you would have to have these pieces as part of your kite to hold the kite in its shape as you're trying to fly it. So if ABCD is a kite, then AC is perpendicular to BD. And so it creates, these two triangles are going to be congruent, and these two triangles are going to be congruent. So two different pairs of congruent triangles. And then our sides, these would be our congruent consecutive sides here, and then this would be the other pair here. Bless you. So let's look at a problem involving kites. Quadrilateral KLMN of a kite. What are the measures of angle 1, 2, and 3? So all they've given us is that this angle here is 36 degrees. So they're going to walk you through this. Diagonals of a kite are perpendicular, so the measure of angle 1 right here, what do we know about that measure of that angle? It's 90 degrees. Perpendicular angles perpendicular lines give you right angles. So triangle KNM, that triangle right there, and a triangle KLM, we actually have three pairs of congruent triangles, right? Are congruent by SSS. Remember, I can single tick mark this side, single tick mark that side, so those are equal. I can double tick mark this side and double tick mark that side because those are equal per the definition of a kite. And then they share this side KM, so that would be triple tick marked. And so by SSS, those triangles are congruent. So the measure of angle 3, if this one's 36, what's the measure of angle 3? also 36 degrees. So doesn't this diagonal of the kite bisect that angle? Also like a rhombus, right? So the measure of angle 1, the measure of angle 2 here is equal to the measure of angle, well, I'm not going to say the measure of angle. I don't like the way they wrote that. We know that this is 90 degrees also, don't we? The measure of angle 2 is 90 degrees minus the measure of what? Oh, they're doing the exterior angle here. I probably would not have done it that way. So let's do it this way. The measure of angle 2 is equal to 90 degrees. Because if this is a right angle, don't those two add up to 90 degrees? Okay. So it's 90 degrees minus the measure of angle 3. So we have the measure of angle 2 is equal to 90 degrees minus, what's the measure of angle 3? From here? 36 degrees, right? So what does that give us? Yep. And so we just found. it. Question? Oh, did I put thank you. That. Couldn't we find all the other angles in there if we wanted to? Do you think that opposite angles are congruent in a kite? Does it look like this angle at K is the same as this angle at M? No. And if, do you think that these angles are bisected? No, not necessarily. Because that angle doesn't look necessarily the same as that angle. So you can't notice that one of the characteristics of a kite is not the diagonals bisecting angles. It just so happens here, it does here and here because you can prove you have congruent triangles for SSIs. Alright, so let's flip it. Good lesson check. So I want you to place a check mark in the box for the description that fits the figure the best and place an X if it does not. You are going to have a check in the box or an X. So a quadrilateral. Is a kite a quadrilateral? Yes or no? Yes. How about a rhombus? Yes. And so you're going to answer that yes or no. A yes is a check, a no is an X. So go ahead and finish through there. And I want you to compare with those around you, see if they agree with your checks and X's. All right, you ready? Are you ready? All right, so here we go. So perpendicular diagonals, we already talked about the fact that that is a characteristic of the kite, which is also similar to the characteristic of the rhombus. So those are both yes. The diagonal bisects a pair of opposite angles. That is a characteristic of the rhombus. It does not happen to, that does say bisects a pair of opposite angles. In a kite, and so I guess you could argue this one. In a kite, it does bisect a pair of opposite angles. But it depends on which one. It doesn't bisect all the opposite angles. So I guess it depends on how you read that one. Congruent opposite sides. Specifically, the kite definition says that there isn't any pairs of opposite sides congruent. But in a rhombus, since all sides are congruent, that has to be true. Two pairs of congruent consecutive sides. The rhombus, all sides are congruent, so that means the rhombus, and that is the definition of a kite. Here, two pairs of congruent opposite angles. So with the rhombus, that's true, because it's a parallelogram. With the kite, they don't have a characteristic that says so. But if you look at your angles on a kite, so like here's a kite here, those have to be the same, true? And don't those have to be the same? Yes or no? Right? And look at this one. Those have to be, are those the same? No. So, I mean, it depends on how the kite is drawn. So, obviously here, this one is not the same as that one. These two appear to be. But that one, not so. And in fact, if you draw a diagonal through here, we're just going to, this is off of your practice sheet. You draw a diagonal through here. Aren't these the triangles that are congruent? By S, 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 right? And so, doesn't this diagonal get bisected? Diagonal, doesn't that angle get bisected? But the whole angle is 101. Those sides are going to be what? 50 what? 50.5. And then this angle they're telling you is 48, so they're obviously not the same. So this angle here is going to be what? 24 and 24, 50.5, 50.5. But these, aren't those going to be the same? So you're typically going to have one set of angles that are the same, one that's not. So for this one, two pairs of congruent opposite angles? No. It should. Emphasis on true. And then supplementary consecutive angles. Because the rhombus is a parallelogram, it has that. The kite, not necessarily so. It might end up happening, but not necessarily so. So you might want to study those because those could be questions on your test. I want you to summarize, how is the kite similar to the rhombus then? You just made a table up regarding that. So I want you to write out how a kite is similar to the rhombus. So you have to mention in their each of those three things that we have above, the fact that they're both quadrilateral, the fact that both figures, the diagonals are perpendicular, and in both figures you've got two pairs of congruent consecutive sides.